Well, hello there. Welcome to another topic from 8th grade math, and we are starting Unit 8 today. Unit 8 is all about functions. So, today's question as we start this unit is, what is a function? What is it? What's a function? Okay, that's the question. Let's see what the answer is. First, we know what this is. This is an equation, okay? And we've dealt with equations before, and we've even taken equations and we've made tables out of them. Like, if you look at this equation, if we plugged in 0 for x, you'd get 0 plus 1, which is 1, right? Y would equal 1. And if you plugged in 1 for x, y would equal 1 plus 1, which is 2. And if you plugged in 2 for x, then y would equal 2 plus 1, which is 3. And if you plug in 3 for x, y would equal 3 plus 1, which is 4. And we've done this before. And we've actually even used this to turn that equation into a line on a graph. What I want you to see now is that this is called a relation. Okay, a relation is a set of ordered pairs. It's pairs of numbers that make that equation work. There's a bunch of other pairs of numbers that wouldn't work, like if you plugged in 0 for x and you said y came out to 175,000, that is not a part of this relation. This relation, each y has to be one more than the x. And you could actually take those ordered pairs and write them like ordered pairs the way you would write it if you were going to put dots on a graph. So this is called a relation. Something you need to know about relations is you can break up a relation into two sets. The first set is called the domain of the relation, and the domain is the x parts, or what we're going to call the inputs, right? Because we put 0 in and got 1 out, and we put 1 in and got 2 out. Those are the inputs, and the technical name for that set of numbers is the domain. The domain is all the x parts, or all the starting parts, or all the inputs. Okay, so what's the other parts? What are the y's? That group is called the range of the relation. And the range it's all the second parts. It's the y parts. It's the outputs. It's what you get out of the equation. So, this is a relation. The relation can be written as an equation. You can write it as a table, or you can write it as a set of points, a set of coordinates, a set of ordered pairs. And you can break that relation up into the domain set and the range set, the inputs and the outputs, the x's and the y's. But not every relation is a function. Sometimes a relation is a function, sometimes it's not. Let's take those same 4 points, those same 4 ordered pairs. A function is a set of ordered pairs where each input only produces a single output. So like when you plugged 0 in, you only got 1 out. You didn't get 1 and 13. You didn't get 1 and negative 75. When you put 0 in, you got 1 out. There's only 1 output for that input. Same thing when you plug 1 in, you got 2 out. When you plug 2 in, you got 3 out. When you plug 3 in, you got 4 out of that equation. So this is a function because for each input number, you only get 1 output number. Here's an example that's not a function. If you plug 0 in, you could get 5, or you could also get a 7 because 0, 5 and 0, 7 are both part of that relation. If you plug 4 in, you could get 8. If you plug 4 in, you could get 4. Okay, this is not a function. And the reason that it's not a function is the 0 input has 2 different outputs, and the 4 input has 2 different outputs. So a function only works when each input gives you 1 output. All right, so is this a function? If you look at this graph and you look at those 4 points, well, if you plug in negative 4 for x, you can see that the y would be negative 2. And if you plug in negative 1 for x, you get positive 2 for y. If you plug in 3 for x, you get 4 for y. And if you plug in 4 for x, you get -3 for y. Those are each one output for each input. So does each input have only one output? Yes. That is a function. Okay, how about this one? We have a table. Let's look at the table and see that there's 4 different inputs and 4 different outputs. And then let's graph them. 2, -4, -4, 0, -2, 3, 3, -1. So is this a function? Yes, because each input gave you a different output, and each input only had one output. Is this linear? No, but is it a function? Yes. All right, how about this one? If you plug in -1, you get +4. If you plug in 2, you get 3. If you plug in 4, you get -1. So it's not linear, but it still could be a function, except that if you plug in -1, you also get -2. So putting in -1 could get you +4 or -2. That's not a function. Okay, and if any 2 points on your graph are stacked on top of each other, north-south, right above or below each other, then you know it's not a function. So if you're looking at a graph and you're not sure if it's a function, just look and see if the graph has any points where one's right above the other one. All right, so here's what I want you to do. I want you to write or draw or graph one example of a function, and then write or draw or graph one example of a non-function. You can do it by drawing a little graph and putting some dots or lines or curves, or you can write out an equation or a table that shows something being a function, or you could write out a list of points that is a function and a list of points that isn't a function. Any of those would be okay. Okay, one more thing. We already saw this function, and so y equals x plus 1 is a function. What we will say here is that y is a function of x. The reason we say that is because when x went up, y went up with it. When you plug in a number for x, that's how you get a y. You can't really get a y without knowing x. And so we would say y functions as x. Y is a function of x. Y kind of depends on x for its value. So y is just a function of x. Okay, so then knowing that y is a function of x, we're going to say, whoops, sorry about that, backwards. Here we go. Knowing that y is a function of x, we're going to say that sometimes to show that y is a function of x, we write this weird thing, f parentheses x, instead of y. That f parentheses x looks like you're multiplying two things, because usually in math, that's what multiplication, or that's what parentheses look like. Parentheses mean multiplying, right? But this time, it doesn't mean you're multiplying something that's f times something that's x. This is just a shorthand way of writing function of x. So whenever you see an f and then a parentheses with an x inside, that means we're talking about a function of x. And so instead of y equals x plus 1, we could write f parentheses x equals x plus 1. And the way we say that purple equation there is we just, instead of saying function of x, we say f of x, meaning function of x, but we just do it quicker by saying f of x equals x plus 1. F of x equals x plus 1. That's what that f parentheses x means. Now, let me show you what we're going to do with that. We're going to then figure out that if you plug 1 in, you get 2 out. And if you plug 9 in, you get 10 out. The f of x notation is just a way to figure out what you get out with what you put in. So if I wanted to figure out what I get out of this function by plugging in 100, I'm going to say f of 100 equals 100 plus 1, because I'm going to plug 100 in for x and get 101. So here's another example, and here's a more complicated function. f of x equals x squared minus 1. So find f of 5. That means wherever there's an x, you plug in a 5. So I'm going to plug a 5 in for the x, and since the x is getting squared, the 5's going to get squared, which is 25, and then we're going to subtract 1. So f of 5 comes out to 24. What would f of 7 come out to? I bet you could figure this out. You're going to plug a 7 in for x and then square it and then subtract 1. So 7 squared is 49, and then you take away 1 and you get 48. This is actually pretty easy to do. So you might have some problems where you get a function and then it asks for f of 5 or f of 7 or f of 28 or f of -1 or f of 0, like this last practice problem. And on this practice problem, your function is f of x equals 7x plus 3. I just want you to find f of 11. Your answer should just be a number that comes out when you put 11 in for x. All right, that's all I got. Thanks for listening. Thanks for watching. Hope you took good notes. Feel free to rewind if you need to review anything, and make sure to write down any questions you have for class tomorrow. Adios.